YouTube is live. Alright, continuing the work on the PCBs that I've designed using GCAD. This is the motor driver design, which is very well documented throughout many videos that I've recorded for the last 2 months. And at this point I'm going over all of the parts of the PCB to bring up all of the peripherals. And a lot of this work is about writing the necessary device drivers, configuring things, and just making sure that everything works as intended. So in the last few videos I have brought up the power rails, and I've been able to flash the CPU and access the UART. So let's have a look at the board. This is what the board looks like. It's running, it's blinking a LED, but it still just outputs things to the UART. So what I'm going to do today is add a console here so that we can have an easy way of debugging what we're doing with the different peripherals on this board. So I have a console as part of libfirmware, which I developed over the last few years. I've had it on GitHub previously as libk, libdriver, like it had a lot of different names. But I settled for splitting up things a little bit between libfirmware and libdriver. And libfirmware is the part that implements the FreeRTOS layer, where we can create threads, we can have basic data structures like lists, and the basic driver framework that loads things using libfdt, reads the device tree, parses the compatible strings, calls the necessary set of functions in drivers. So all of that is in libfirmware, and I still have libdriver, which has a bunch of different drivers that I've both written myself and found online before. So it contains a lot of different code that some of which is very, very old. So at the moment it doesn't even compile properly. Like all of the drivers don't actually compile. So I'm moving many of my drivers to device tree, and console is one such driver that I haven't moved to the device tree yet, but which I want to move to the device tree so that I can easily configure things like the amount of stack that the console process takes, basically like any parameters that are application specific, that may be board specific. I would like to configure through the device tree. So let's have a look at what we need to do here. So we have our console implementation here, and currently this implementation just has a public method that starts a thread which implements the console. And we want to move this to the device tree just like I did with the previous driver. Let me see here. And the way we're going to do that is we're going to move this to the driver framework. We'll have a method called, or actually a definition, which we invoke, called driver init, or no, wait, device driver. Let me see. I usually just copy my own stuff, so I don't really keep track of all the syntax details. So let's see, F46. So just like I do on the UART driver, I'm going to define a console driver here. actually it's going to be just console, and it's going to be part of lib firmware, just to make it separate from any possible other implementation of console. And this would be console probe and console remove. And as I said before, probe and remove, they aren't actually, the probe is used, but the remove is not used. I don't really implement them yet, because on the embedded target, it doesn't really matter. The application never stops. The chip just resets. The only thing that can happen is the chip resets, and then everything starts all over again. So we don't need to free any memory. But it's probably also good practice for me to add those things, because, for example, if I compile for the Linux target and run valgrind, then it's very good to free any allocated memory when the program exits. And that's what the remove method is for. And then we'll just move this code into console probe. And this will accept, let's see, this one will accept the FDT and FDT node. And this will be called from the driver initialization code. And what we need to do here is create the console object. So we do struct console self, and we allocate this. In my firmware, I'm using the simple heap implementation. So allocations, actually, like in the free artist, there are different implementations of the heap, and some of these implementations allow you to free memory, and others only allow you to allocate memory, and then basically you allocate memory when you just start your application, and then you never deallocate that memory. And I think that's a very good practice to employ when you only allocate things at startup and like during the initialization, and then you never deallocate those things. You just use the buffers that you've allocated. So essentially it becomes like using static allocation, but you get the benefit of being able to dynamically allocate memory based on your configuration, and perhaps anything that you may not know at the time when you're writing the application. I think that's very useful in order to not waste any memory, but instead you just allocate just as much as you need, and just use that memory throughout while the application is running. And then you never deallocate the memory. You never call free on anything, which improves the reliability of the application and prevents any kind of failure that can be caused when you are not able to allocate any more memory. We're going to create this, and this would be size of struct console, and then we create a thread for the console process, so that it runs as a separate process. And the console process then takes care of the user input based on the UART that we provide for reading the user input, which is also something that we're going to configure through the device tree. In the device tree, we can add references to other nodes, and the libfdt API is a little bit convoluted, I would say. It's not very intuitive, but a lot of the things that we want to do are easily achievable using the API that libfdt provides. And I will check. Let's see. Did I implement this as part of the CPU driver? Nope. Let's see. I'm looking for some code that that uses the libfdt functions to get reference from like a reference to another node in a device tree. I don't remember what function. I think it's like fdt get node, but then it returns a pointer, I think, to the node, and then we can just use that that node to get properties of that node. But what we're going to be doing here is getting just the name of that node, and then we will find the serial port that that has been initialized with that name. Let's see. libfdt get node. Right, I just remembered where I can have a look. So in the driver for this. So one way to do this is to call find node by ref, which essentially gives us the integer that corresponds to the node ID. So it's the same as this fdt node. So this fdt node points to the node which belongs to the console, and this fdt node will be the node that points to the serial port. And we could say if this serial port, so that function will return less than 0. I think it will return -1 if it doesn't find the node. So we can do a print k console serial port missing. Print k will print to whatever serial port that has an option of being the default serial port for any output. And we return an error from this function. And then what we'll do here is, let's see. So I think we can get the node name. Or we could do let's see if my serial driver supports this. We can do serial. So serial port would be our serial port, and it would be serial find by node. When each device driver registers a device, it also supplies its fdt node to the register function. And this is part of the lib firmware where there are different classes of devices, and the idea is that you register devices with generic interfaces, which you can then use from other drivers. So find by node from fdt and this node. And if let's see, so if this serial is not found, then we do print k and now we can call the console init on this self. Let's see, and then we have serial port commands. So something that I need to also refactor is the commands, the way that commands and data variables are provided for the console, because we are not going to be able to use console init anymore. Instead, what we'll do is implement a console interface, where other device drivers can easily add commands to the console using the same concept of device tree as I'm using here for getting the serial port. So for now, we can just do like this. We'll do serial null 0 null, and then we create the console task, and I think we should be able to run the console now. So let's add the console to the device tree of this firmware, and let's see if we can get the console running on the terminal. We need to add the console after the serial port. We can add it here. So compatible will be the driver name, and serial will be a reference to this debug UART. So we just say debug UART. And another thing we need to add also is the console driver to the build process. So we're building for 429 ZET6, and we need to add our module here. So because everything is compiled as libraries, as static libraries, and because the driver registration code relies on static construction, if we place that code into libraries, it will actually be discarded by the linker, because there is nothing actually referencing that code from the starting point. So what we need to do, that code is only referenced by data. So what we need to do is actually explicitly specify that we want to include a driver into our firmware. So this will be console CO, and this is basically just a symbol name that the device driver macro registers, and it just adds a KO on the as ending of the string that you specify here, and that's just to separate the symbols from anything else that may be called console. So now we can flash this, and let's see if we can even compile it. And then we should be able to see the output on the terminal in the window over there. So let's see once it compiles, and once it flashes. Going super duper slow. I think it's the video encoder that takes most of the CPU power, and also the YouTube application that runs in the browser takes a lot of CPU power. So I forgot to include the libfdt, so I'm going to go ahead and do that. My libfdt is actually a little modified. I've added some utility functions. You could check the Git repository to see what I've added. And also we need to add the serial. Let's see, so this actually should be there. Why do I not see the serial? Maybe I called it serial device. Let's see, serial. Right, okay. I need to add the serial find by node, which I could just copy from, let's see, was it GPIO? I have the find by node implemented for. Yes. So I'll copy this from the GPIO, for the GPIO driver. And let's see, find by node, but it will instead return the serial device. This is a bit of copy pasting in the different subsystems, because it's basically the same code. It just returns different pointers. But the flexibility that this adds is absolutely worth it. Because no device driver needs to know about what type of serial port it talks to. It could even be another device driver. It doesn't even have to be an actual serial port. But they can still communicate, and they communicate over generic interfaces. So serial port T, and this would be serial find by node. And what we'll do is just call this serial device. And for each entry, serial ports. Yes, it's basically the same thing. And if the node matches, we return the device. Serial H. Let's see. We'll add this here. And let's see what else we have. We have serial find by node. Console, yeah, of course. Actually, I should be returning -1, so I can see which ones are not implemented later. So let's see. Oh, yeah, and this macro shouldn't have any, because I have the maximum warning level enabled. I cannot have any stray semicolons. Let's see. Okay, this is really slow. This is to the point where I think I need to check what it is that takes all of the CPU power. Yeah, it's FFmpeg and Crow, which runs the YouTube interface. Okay, let's see, what did we get here? We have USB. Oh, damn it! I haven't added that to Git, so I need to actually copy that. Let's see. I think I should have this. Let's start a new terminal. So let's move this. I think it was in TMP. Where and then source USB. Lib driver, yeah, lib driver. Oh no, did I remove that? I think I have a copy. And let's copy this to source, libdriver, source, and then we should be able to build this. Actually, let's build it here. Okay. I renamed that project to boss init, so I'll just delete any data that has been around there. Let's see if this works. Boss configure. Do I need to update it somewhere else? Boss init is just the startup process, and I thought it was better to call it boss init. Let's see here. So, right. And then I need to also update any dependencies which I have. Probably forgot to update the dependencies somewhere else. So let's see. Let's. I think it could be here. So. Although it's hard to find this because it's going to be defined as just makefile placeholders. So I'm going to go to rules. Okay. Let's see config. So. Oh, I think maybe the firmware depends on. Yeah, here, of course. Yeah. Right. So I was overriding that section in my in the application-specific firmware, which caused the build process to not find the correct directory. Yeah, now it flashed. Did we get a console here? Let's see. Yeah, we have a console! It gives us internal error, but we still have a console. I think internal error is because I didn't provide any commands. This is what the console looks like. I'll have to fix the internal error, and I will continue to move the console code to device tree. Let's actually see if we can figure it out right away. What the internal error means. So if we are reading and we get we're unable to read a line, then we get internal error. So the question is why we are getting an error there. Why we're getting a negative return value, which could be, let's see.